bug we're talking about today is a hacker's wet dream. It is a bug in an SSH server that doesn't require memory corruption and allows you to get access to that server with no credentials. Truly insane. In this video, I'm going to demonstrate the exploit, show you how it works, and talk about how this exploit on the right was actually written entirely by AI. Kind of crazy. Real quick, if you're new here, hi, I am Low Level. I am an offensive security researcher and security engineer in my day job. I like to make videos about cybersecurity incidents, software security, and all that cool stuff. So if you're into that or just want to hang out with me, hit that sub button. I really appreciate it. Now, to set the stage, it is important to understand that this is not a bug in OpenSSH, right? If this bug were in OpenSSH, this would be one of the craziest bugs, craziest scenarios on the face of the planet, because this bug, again, does open up your server to anybody with no credentials. The bug, luckily, and luckily is in quotes, is in Erlang. What is Erlang? Erlang is a programming language used to build a massively scalable, soft, real-time systems with a focus on telecom, banking, e-commerce, and instant messaging. So maybe it's not great that it's in Erlang, given that Erlang is likely used in telco stacks. Erlang was actually written by Ericsson. Ericsson is a manufacturer of giant telephony switches. And so the fact that Erlang exists, and Erlang supposedly or likely is on Ericsson telephony switches, and this bug is in SSH within Erlang, not a great place to be. But yeah, so this is not a bug in OpenSSH. Very important to understand that. One interesting thing about this entire scenario is that originally this whole story kind of just started as a tweet, right? Horizon 3 tweeted that they had a working concept for this vulnerability, but didn't want to disclose a proof of concept. That's typically a responsible disclosure thing, right? Because until a patched version exists, they don't want to give people the exploit code unless there's a way to mitigate the exploit, right? And so this team called Platform Security, I have not heard of them, but there you go. They actually used AI to take the clue and then go and diff the version. So here in the patch, they literally say what version of OTP is vulnerable to this attack. And so all they did is they went and got the vulnerable versions of OTP, and then they said, hey, ChatGPT, do me a favor. Can you write a script that diffs the two versions and shows us all of the code that has been changed? And then eventually they asked ChatGPT to analyze the code, and right there they find out that, boom, you can just send a particular kind of message to the server that allows it to run code before you actually authenticate. There's no check if the session had been authenticated or not yet. You can just say, hey, can you do this thing for me? Which is pretty crazy. And even better, they had ChatGPT take the code that exists here and write a proof of concept in Python, which we're going to demonstrate here in a second, to literally open the channel, to do a key exchange packet, and then to send the, hey, can you execute this command packet, which is truly crazy. And then eventually they use Cursor to debug some issues. We're not going to get into that. I do want to say, I think also at more of a weird meta level, this article is also written by AI, given just how flowery the language is and how there's emojis everywhere. I don't think regular people write like this. And Platform Security, if I'm wrong, tell me, I'm sorry, but it also looks like ChatGPT wrote the article. So anyway, so for the proof of concept here, on the left we have Erlang, we have the Erlang interpreter running, and what we're gonna do is we're gonna copy and paste in our little proof of concept code. All this does is use the OTP library to start an SSH server, and then you get the, was it okay, and the object of that SSH server daemon as a return value by creating a daemon on port 2222. The rest of the stuff doesn't matter. It's just setting up the folders and the host keys and stuff. And so with this running, we now have an SSH server that is open on port 2222. This is running inside of a Docker image Erlang version 2732. And then now it is running, and that port is forwarded to my local host in the virtual machine here. So now we're going to run the exploit. The exploit, like I said, is honestly pretty straightforward. All we do is we do a proper SSH key exchange, right, or an SSH session establishment. We exchange the banners of each other. So typically what happens is when a client connects to a server, the client says what version of the client they are, the server says what version of the server they are, and then they begin a key exchange, right? Once the key exchange has finished, they open up a message channel for them to send data, and then what's supposed to happen is they do authentication. So they have they've exchanged the data about what key exchanges they can do. they use that key exchange to open a channel, and then inside the channel, they do authentication. Well, you'll notice here that we can send data over the channel and make requests before we even do authentication, right? And what we're gonna do is use a proof of concept to write the file lab to the top level, and it says pwned here. I'm gonna make it say trollolololo or something, just kind of make it a little fun. So all you have to do now is run the server, or run the exploit rather. You'll see here, so the server, we connect to it, we receive the banner here, and then we get some response about the key exchange here, but in the background, it actually ran and wrote this file to lab. And so if we go here, we can do the date time is, April at 2:30 UTC, and if we go and we ls in this lab file that was also written at 14:30 UTC, and if we cat this, it says trollolololo. So really, really crazy stuff. Again, thank God this isn't an OpenSSH, right? Thank God this isn't a bug in OpenSSH. Now, that being said, like I said before, the fact that it's in Erlang is not great. Now, the question you all want to know, would Rust have fixed this? The answer is no, right? This is not your traditional memory corruption exploit or race condition where a spatial boundary of memory has been violated or there's a weird temporal access pattern. In this case, this is just literally a logic error where they're not checking if authentication has been completed before accepting channel request messages. This is one of the few instances, or maybe not few, this is one of the instances where rewriting a code base out of C, getting a code base that exists in C and writing it somewhere else may actually be a bad idea. The reason for this is the OpenSSH code base that does this whole process in C that you can use as a library in Erlang is so heavily audited that it's been through so many, iterations of security review and fuzzing, and it's been looked at so often, like Heartbleed and all these big bugs. It's almost safer to use a memory unsafe language where the code has been tested through time and everyone can generally agree that it's as safe as it's gonna get, right? Obviously bugs are probably in OpenSSH, it's somewhere hiding in there. But the problem is when you do something like this where you use Erlang, or even Rust, you have to re-implement not only the memory, the spatial part of the protocol, but the logic of the protocol. And that is where languages like Erlang, like Rust, like Go, any language that is memory safe, they don't offer the ability to just write logic bug free code, because that's where the human comes in. That's where the layer 8 person comes in and makes the protocol happen. And so an error like this is just not preventable by a language. This is a human error thing. Whoa, no way. Speaking of Rust, hey guys, real quick, shameless plug. I do have courses on my site, Low Level Academy, like 0 to Hero C program, where you can learn to write C and learn how computers work at a basic level. You can learn to write network code in C, threading in C, build your own HTTP server. Oh, and also a Rust course is coming at the beginning of next month. Right now the courses are all on sale. Get them for this low price here. Get access to every course for this price and learn how computers actually work. Anyway, back to the video about Erlang vulnerabilities. And so if you're going to redesign a protocol and you do it in a language like this, you're adding that risk to your code, which is interesting. Anyway, guys, that's it for now. If you like these kinds of breakdowns, if you like the CVE review stuff, do me a favor, leave a comment down below, tell me that, and then hit subscribe. And then go check out the video about the 4chan hack, because it's honestly insane that 4chan lasted as long as it did based on how old it was. We'll see you over there. Bye-bye.